Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 31, Problems in Mathematical Terms. So, classwork example 1 says, Marcus reads for 30 minutes each night. He wants to determine the total number of minutes he will read over the course of a month. He wrote the equation P equals 30D to represent the total amount of time that he has spent reading, where T represents total number of minutes read, and D represents number of days he read during the month. Determine which variable is independent and which variable is dependent. So now we're talking about independent and dependent. So if something depends on something else, then it is dependent. So, for example, I am a dependent of the U.S. Navy because my wife is in the military, and therefore I am a Navy dependent. I cannot go on base unless I have unless I'm in the military or I am a dependent. So me getting on base depends on whether or not I am married to someone in the military. So they call them dependents. So I can't get on base. So therefore, I am dependent upon having an ID of a relative that is in the military to get on a military base, or any military base, I suppose. An independent variable means that they are independent of anything. So if you are military, you are already able to go on to base, obviously, because you're in the military and you have to go to work and so forth. And you are not dependent on someone else being in the military to get on that base. So that's one example I can use, like dependent. But in this problem here, dependent is an independent. Okay, the variable that's by itself is the dependent variable. So the dependent variable here is t, and t represents total number of minutes read. So I'll write that here. Okay. The independent variable is the variable that we're going to plug into the equation, and t depends on what we put in for d, and that's why we call them dependent and independent. So the independent variable is d, and d represents days, number of days. So over here, I'm going to do dependent. Actually, I'm going to do independent here. I'm always thinking alphabetical order. This is going to be independent. And this is going to be the dependent variable. So in other words, the independent variable that we chose was D, number of days. We can say number of days, D. The dependent variable is going to be number of minutes read. READ, not RED. Okay, and that's going to be T. So we have this equation, T equals 30D. So if I plug a value in for D, and I'll put it here, then we are going to get a value for T. So my equation is T equals 30D. So D is independent, but T depends upon what we plug in for D. T will change with every D we plug in. So if I decide to put 1 in for D, that means I'm going to put a 1 here. Well, T depends on what D is. And if D is 1, 30 times 1 is 30, so therefore T has to be 30. So if I write that equation again, T equals 30D, and then I replace D with some variable, or value D, okay, my D independent variable. I plug in something, T depends on what D is. D is 2, and when D is 2, T equals 30 times 2, or 60. So when D is 2, T is 60. Okay, so T depends on. Okay, so now I'm going to continue this. So if I plug in a 3 here, 30 times 3 would be 90, 40, 4 times 30 is going to be 120. 5 times 30 is 150. 6 times 30 is 180. And 7 times 30 is 210. So let's check that last one. If I say t equals 30d, and I substitute in my independent variable, which is 7, and I multiply 30 times 7, 7 times 0 is 0, 7 times 3 is 21, I do in fact get 10. Okay, so my independent variable is number of days, my dependent variable was number of minutes per day. Okay, let's try it again. Here's example 2. Kira designs a website. She can create 3 different websites each week. Okay, Kira wants to create an equation that will give her a total number of websites she can design given the number of weeks she works. Okay, determine the independent and dependent variables, create a table, show the number of websites she can design over the first 5 weeks. So 1, 2, 3, 4, 5, first 5 weeks. Finally, write an equation to represent the number of websites she can design when given any number of weeks. Okay, so the independent variable in this situation is number of weeks worked. Okay, the number of websites she creates is not the number of weeks she works does not depend on how many websites she creates. You wouldn't say, oh, well, she created 6 websites, so she must have worked 2 weeks. We don't go that direction. We would say, if she works 2 weeks, then she could make 6 websites. It makes more sense that way. So the dependent variable is therefore number of website design. So the dependent variable is the number of websites designed. Okay, so if I just simply write that over here, the independent variable goes first, independent, dependent. So the independent variable is number of weeks worked, and we'll call that W. Okay, and number of websites designed, let's call that D for design. Okay, because W starts with, our website starts with W as well as weeks, so we can't use W twice. So now we need an equation. The dependent variable is always by itself, and the independent variable is having an operation performed upon it. And 3 websites each week, so that'd be 3 per week. So the equation is the number of websites designed equals 3 times the number of weeks worked. So if she works for 1 week, if she worked for 1 week, then we plug in 1 for W or substitute. So D equals 3 times 1, so D equals 3. So if she works 1 week, 3 websites will be created. If she works 2 weeks, W now becomes 2, and when W is 2, D is 3 times 2, or 6. So on and so on. So 3 times 2 is 6. So therefore now when we take 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And then the website's given any number is this equation here. Okay, so if I work 10 weeks, she would have created 30 websites. Or if she works 10 weeks. Okay. Example 3. Priya streams movies through a company that charges her $5 a month plus $150 per means times movie. I'll call that M. And so then there's a monthly fee. We'll call that F. Well, that's a monthly fee. That's going to be our constant. So let's not use the fee. Well, we can. Let me do that. So I'm going to show you how to set up the equation using all these variables and then plug in. And let's see, it says determine the independent dependent variables, write an equation to model the situation, and create a table to show the cost per month given that she might stream between 4 and 10 movies in a month. So here's my title section. So I'm starting with 4, 5, 6, 7, 8, 9, and 5, and 10. So that's the 4 through 10 right here. That is my independent variable. My dependent variable goes over here. We just need to determine what those are. So it says right here, streaming 4 to 10 movies is the independent variable. So the independent variable is number of movies streamed. I'll just write number of movies. We'll call that M. And then the dependent variable is how much is it going to cost you? Total cost for the month. I'll just write total cost for now. We'll call it C, cost. So the independent variable is M, number of movies, and the dependent variable is C, cost for the month. I'm not going to write all that because it's already over here. So now we need an equation. Well, if we look up here, then we have a total cost equals $1.50 times however many movies we rent plus that monthly fee. So that's what I'm going to start with here. But we know the monthly fee is a constant $5. It never changes. So my actual equation is going to be C equals $1.50 times the number of movies we stream plus the $5 monthly fee. So this equation actually should be different. Okay, so I just wanted to show you where that came from. Now let's get this out of the way. And now we're going to start calculating values. So in order to solve this for C, what we're trying to find is the C values. C equals $1.50 times M. Let me use a different color for M. Times M. I want to point out to you what we're substituting in. And plus $5. So when I do that, my M in my first one is 4. So now I'm going to calculate that. $1.50 times 4 is $6. Plus the $5 monthly fee. Total cost if you stream 4 movies is $11. Okay, so I'm going to put $11. Okay, let's do that one more time. C equals $1.50. Let me change color so you see it's a different equation. So I'm going to do the same thing over again. C equals $1.50 times some value we're going to plug in for M plus $5. This time my M is 5. That's why I put a 5. Let's make it red so we remember it. Okay, so there's our 5. So C equals $1.50 times 5, which is $7.50, plus our $5 monthly fee. So when we rent 5 streaming videos, it will cost us $12.50. Okay, so I'll put that over here. $12.50. Okay, I'm going to do it one more time, and you'll see that there's a pattern. C equals $1.50. Convert this M to an independent variable of our choice, and our choice is now 6. So C depends on what we plug in for our equation. C depends on this right here. Okay, so C depends on what we plug in for M. M is 6, so we're saying what is C when M is 6? So C equals 6 times 0 is 0, 6 times 5 is 30, carry the 3, 6 times 1 is 6, plus that 3 is $9, plus, if you want plus sign, $5 here, so the total cost would be $14. So if I write $14 here, look at what's going on now. 11 to $12.50 is a change in $1.50. Changing from $12.50 to $1,400 was an increase in another $1.50. So what we're doing, multiplication is repetitive addition. So $14 plus $1.50 is $15.50. Plus $1.50 is $17. Plus $1.50 is $18.50. And plus $1.50 is $20. Okay. Exercise. Now it's your turn. Try these 3. Come back. See how you did. Okay, so Sarah purchases pencils to share. Each package has 12 pencils. The equation n equals 12p, they gave us the equation, is our equation where n is the total number of pencils and p is the number of packages. Can be used to determine the total number of pencils Sarah purchased. Determine which variable is dependent. Okay, the dependent variable is always by itself, so I'm going to just label it like this. The dependent variable is n, and n is the total number of pencils. That's the dependent variable. The independent variable is p, and p is number of pencils. Okay, number of packages. P is the number of packages. Okay, so there's our dependent, there's our independent. So we answered that part of the question. Then make a table to show the number of pencils purchased for 3 through 7 packages. Okay, so here I'm going to put the number of packages, P, and this is going to be total number of pencils. And that is going to be n. This is independent, this is dependent. And it says for 3 to 7 packages. So that's telling us what to put in 3, 4, 5, 6, 7. So these are our independent variables. We're going to plug them in. N depends on what P is. So now I'm going to do N equals 12 times P, and P is 3. So N equals 36. N equals 12 times P. P is 4. 12 times 4, so therefore n equals 48. And so on and so on. I increase by 12. I'm going to do one more and make sure I didn't make a mistake. 12 times 5, n equals 60. So if I have 5 packs of pencils and there's 12 in a pack, I will have 60 pencils. So this is increasing by 12 every time, so that's how many are in each package. So 60 plus 12 is 72, plus 12 is 8. Again, repetitive addition is multiplication. Okay, number 2. Charlotte reads 4 books each week. Let B be the number of books she reads each week, and let W be the number of weeks that she reads. Determine which variable is dependent, which is independent. So the independent is going to go here, and the dependent is going to go here. Okay, and if we come up with an equation, and it says, then write an equation to model the situation and make a table that shows the number of books read in under 6 weeks. Under 6 would be 5, 4, 3, 2, and 1 week. So there's our variables, and there's our key right there, 6 weeks. So that is our independent variable, is number of weeks. The dependent variable is B, and this is number of weeks, W. And this is going to be B, which represents number of books each week. Number of books she reads. Okay? Okay. So we have the equation. Charlotte reads 4 books each week. Okay, so B, Charlotte reads 4 books each week. B equals 4 per week. Okay, our dependent variable is by itself. Independent is with on the other side, and that's what we calculate. So if I'm going to do this, I'm going to say B, number of books, equals 4 books per week. And if I read 1 week, 4 times 1, number of books I read in 1 week is 4. B equals 4, W. B equals 4, and replace W with my independent variable, 2. So B equals 4 times 2, which is 8. And we continue this because now we see a pattern. And if I plug in a 3, it's 4 times 3, or 12. 4 times 4 is 16. 4 times 5 is 20. It's increasing by 4 every time. Okay. Next exercise, number 3. Try this one, pause the video, come back, see how you did. Okay, here we go. A miniature golf course has a special group rate. You can pay $20 plus $3 per, that's multiplication, person. So I'd call that 3P. How's that? Okay, 3 times P. When you have a group of 5 or more friends, let F be the number of friends and C be the total cost. So the cost is going to depend on how many friends you have, so F is going to be the independent variable. So independent F, okay, number of friends. Okay. Dependent variable is C, total cost. Okay, it says when you have a group of 5 or more friends. So that's just telling us what to plug in here. We can't have 4, we have to have 5 or more. So we're going to go from 5 to 12. Okay, so now we have our independent variable, we have our dependent variable. The dependent variable is all by itself. We solve for the dependent variable, so we say the dependent variable, or C in this case, equals, and here's the calculation, $3 per person plus $20 is what it costs. And now we're going to calculate. We're going to replace our P with our independent variable 5. So my equation is going to say C equals 3 times 5 plus 20. Don't forget your order of operations. Says to multiply first and then add. So the total cost is $35. Okay? So I should say the total cost in dollars here, so I don't have to write dollars every time. So that's $35. So then if I plug in 6, C equals 3 times 6, okay, plus 20. So C equals 18 plus 20, C equals 38. So it's increasing by our coefficient value here. It's increasing by our coefficient, $3 per person. $20 doesn't change, so all I'm doing is adding 3 now, so that's quicker. So I'm going to put 38 plus 3, 41 plus 3, plus 3, plus 3, plus 3, and plus 3. And I'm going to check that last one just in case. So there's my equation. C equals 3P plus 20, and P is 12. So C equals 3 times 12, or 36, plus 20, and C equals 56, and that is exactly what I got here. Okay. Hopefully this is getting really easy for you and just becoming routine. Next one, try this, pause the video. See how you do. Okay, hopefully you had a chance to do this. Let's take a look. Carlos is shopping for school supplies. He bought a pencil box for $3, and he also needs to buy notebooks. Each notebook is $2. There's the key word, each notebook is $2. Let T represent the total cost of supplies and the number of notebooks Carlos buys. Determine which variable is independent, which is dependent. Write an equation, model the situation. Make a table to show the cost of 1, 2, 3, 4, and 5 notebooks. This is independent. This is dependent. So we are trying to find the total cost, T. T represents total cost. That is the dependent variable. The independent variable is going to be each notebook N. N be the number of notebooks. So I'm going to put N here, number of notebooks. Okay, so remember, the dependent variable is always isolated by itself, and it equals the calculation we were doing. So he's buying a pencil box for $3, but he's only buying one. But he's going to buy notebooks, and he knows that they are $2 each. Each notebook, $2 per notebook. That's multiplication. And there's my equation. T equals 2N plus 3. So that means T depends on how many notebooks you buy. The total cost depends on how much you purchase. So if I replace n with my independent variable of 1, then n times 2, 2 times 2, 1 is 3, or 2 plus 3 equals 5. So 2 times 1 is 2. 2 plus 3 is 5. Total cost in dollars is $5 for one notebook and the pencil box. If he buys 2 notebooks, then my n is going to be replaced with a 2, and I'm using a different color to show where the variable was. And 2 times 2 is 4 plus 3, and t equals 7. So we're increasing by the cost of one notebook every time. So that's an increase of $2. So we're going to start at 5 and go to 7, add 2, add 2, add 2. So 5 notebooks cost $13. I want to make sure that's true, so let's try it. So we have 2n, where n is 5, and we're going to add 2 to that. Or 3, I mean, $3 for a pencil box. So t equals 2 times 5, which is 10, plus 3, and t does in fact equal $13. Okay, that is the end of lesson 31. Go do your problem set.